Hello, Kim 107 students. We are here to talk about Chapter 5, which is actually a pretty short chapter. I also wanted to give you a heads up. For Chapter 6, I made that recording a while back, and there's actually a watermark in the video that I didn't know about. So just to let you know, Chapter 6 is going to have a watermark, and so there's nothing wrong with your computer. Anyway, Chapter 5 is about water. Water is obviously very important for life, and we're going to talk a little bit about water in this chapter. So water is the most abundant liquid on the planet. It doesn't mean it's the most normal liquid compared to other liquids, but it is the most abundant, meaning we have more liquid water than any other liquid by far on the planet. You can see the Lewis dot structure right up here for water. We have two single bonds, right? Those are single bonds, and two lone pairs in the Lewis dot structure. It is a bent molecule. The HOH is not in a straight line. The bond angle is a little less than 109.5 degrees. The freezing point of water is 0 degrees Celsius, or that's 32 in degrees Fahrenheit. The boiling point of water is 100 degrees Celsius, which is easy to remember, or 212 in degrees Fahrenheit, which is not so easy to remember. Like I mentioned, water is not a typical liquid. For most liquids, when you freeze them, the ice cubes sink, meaning the solid is more dense than the liquid. But for water, when you freeze water, the ice cubes rise to the top. They float. So ice is actually a little less dense than cold liquid water. Ice floats in water. The solid floats in the liquid, and that is weird. Other liquids don't do this. But this is great because otherwise life probably wouldn't exist. If lakes froze from the bottom up, everything at the bottom would be dead. So all the little animals and all the plants would die, and then the lake would be dead. So we're lucky that water freezes from the top down and it never reaches the bottom. So we're really lucky that ice is the way it is. Here's some fun facts about water from the EPA. You should know what that stands for. Environmental Protection Agency. Yeah. So there's the same amount of water on Earth as there was when the Earth was formed. The water from your faucet could contain water molecules that dinosaurs drank. Water is composed of two elements, hydrogen and oxygen. Two hydrogen and one oxygen, making the chemical formula H2O. Nearly 97% of the world's water is salty or otherwise undrinkable. Another 2% is locked up frozen in ice caps and glaciers, which are melting, however. That leaves just about 1% for all of humanity's needs. Wow, only about 1% of H2O on the planet is available for us to use for agricultural, our homes, residential, manufacturing companies, the community like swimming pools, and personal needs, showers and toilets. So water regulates the Earth's temperature. So if the oceans heat up, the Earth heats up. It also regulates the temperature of a human body, carries nutrients and oxygens to cells, cushions our joints like our spine. We have little discs that are full of water between our vertebrae. It protects organs and tissues, and it removes waste out of our body. 75% of your brain is water, and 75% of a tree is water. I know you think of a tree as being a solid, right? Hard wood and leaves and the trunk, but 75% of a tree is actually made of water. A person can live about a month without food. Wow, I wouldn't want to do that. But only about a week without water. Water is part of a deeply interconnected system. When we pour water on the ground, it can end up in many different places. What we spew into the sky ends up in our water. When we put contaminations on the ground, they end up in the water. So we have to watch about polluting our water, don't we? That's a big problem. Here's the water cycle. So basically the water, again, that exists on the earth has always existed on the earth, and it just moves different places. So the ocean water can evaporate up into the atmosphere. The atmosphere can precipitate back down as rain or snow and ice. Snow melts, it runs down the mountains. We have streams and rivers that flow. That water can evaporate. Some of the water gets soaked into the ground. Groundwater can come back up in springs and in freshwater lakes, and plants can pull water out of the soil as well. We have fog that can come down that contains water. Volcanoes, when they explode, they put steam up into the air. And then eventually rivers run back down to the ocean. And that's where we started. So water just gets transported all over. And we have to be careful that we don't contaminate it in all of these places because it's all interconnected. So eventually it's going to pollute the ocean and the air. I just wanted to remind you of our physical changes or physical processes, solid to liquid to gas. That'll be fair game in this chapter again. So solid to liquid is melting. Liquid to gas is boiling. Or if we're not adding heat to something on purpose to boil it, water does just eventually evaporate. Liquids can evaporate naturally as well. So evaporation. Gases can condense back to liquids. Liquids freeze into solids. And then for a few chemicals, they don't have the liquid state here on Earth's normal surface temperature and pressure. So solids can go all the way to gas, called sublimation, and then gases can go back to solid, called deposition. So again, remember these 6 phase changes, physical changes, phase changes, same thing. Water usage. Water is maybe our most vital earth resource. As it becomes more polluted and more scarce, it's going to become the oil of our day. A typical United States citizen uses 80 to 100 gallons a day on average, says the United States Geological Service, with toilets being the number 1 use, followed by showers. So toilets are number 1 in a home for residential use. So low-flow toilets and showers are becoming very popular to help us not use so much water. I actually have low-flow toilets in my home. They're like the ones in the Phoenix Civic Center where they have a button, number 1 for just a little bit of water and number 2 for a lot more water. So if you've ever been to the Phoenix Civic Center for like Comic-Con or something, those bathrooms also have a 1 and a 2. So low-flow toilets are becoming very popular. Worldwide water usage, 70% is for agriculture. 50% of that is for farm animals. So actually 50% of our water goes to farm animals. 20% is industrial, and then 10% is residential. And again, of that 10% residential, the number 1 residential usage is our toilets. So we can do a better job there. But if I ask about what's the major usage of water in the world, it's agriculture, specifically farm animals. So our water system is very stressed. Today, we're putting major stress on our freshwater resources due to population growth and climate change. Food production needs to grow by like 69% by 2035 to feed everyone, which means we need more water to grow crops and to use animals. If we continue to eat animals, it takes a lot more water for animals than it does for crops. This growing demand is a challenge due to the population growth. Our population really does not need to increase anymore. In fact, it'd be nice if it went down. We have unsustainable water withdrawals. We're pulling water out of the ground faster than it's being replenished for farming. We have poor infrastructure and poor governing. No one's thinking about this. We think our water is unlimited, but it's not. Phoenix is going to have to think about this, right? We're going to have to think about this really seriously in Phoenix. Today, about 1.7 billion people live in unsustained water regions, and that number will increase to 5 billion by 2050. Which is about a little over half of the world's population. So we really have unsustainable water right now. This figure just shows in green that agriculture is, again, the major usage of water withdrawal. We use it and consume it. Municipal is our cities. Sorry, Bambi. Industry is in the light blue. Power generation uses a little bit of water, and energy production is in yellow. So primary energy production includes fossil fuels. So fossil fuels take up some water usage as well as biofuels. Water pollution. Human usage results in pollution. About 80% of our used water goes untreated, meaning we're not recycling it and using it again. We're just letting it go somewhere else. In 2010, the United Nations recognized the human right to safe, affordable, and clean water. But 2.1 billion lack access to clean water and 4.5 billion lack sanitation services, meaning toilets connected to water, stuff like that. The World Health Organization, WHO, reports that poor sanitation of our drinking water leads to poor health, mortality, and poverty. Things that can be transmitted through contaminated water include diarrhea, dysentery, cholera, typhoid, and polio. In 2015, the deaths of 361,000 children under the age of 5 could have been prevented by having clean drinking water. Wow, that's a lot of children dying, age 4, 3, 2, 1, and infants, dying just because they don't have clean water. Climate change is also causing increased droughts and floods. So the number of people at risk for floods is expected to rise to 1.6 billion by 2050, while 3.9 billion will live in areas of drought. Like us in Phoenix, we're in a drought, and water stress, according to the United Nations. All right, now we're going to do a little chemistry about water in the next video. So good luck.